Good day, class. You are welcome back to another section of this integral calculus. So this is a continuation of integral of special form. Now let us take a look at the integral of the form, the integral of the form f prime of x over f of x dx. Remember, f prime of x means dy dx. That is, if you have a fractional integral like this, such that the numerator is the differentiation of f of x. Remember, f prime of x means differentiation. If you have a fractional integral such that the numerator is the differentiation of the denominator, how do we deal with this one? That's exactly what we want to learn in this session. Now, we say let u represent f of x. Then when we differentiate u with respect to x, we are going to get f prime of x. Then we have the u is equal to f prime of x multiplied by the x. Now, the next thing to do here is that let us divide both sides by u. Then we have the u divided by u is equal to f prime of x divided by u is equal to f of x divided by f of x. Then the next thing is let us integrate both sides. We integrate the u over u is equal to the integral of f prime of x over f of x. Then the next thing here is, you remember this is 1 over u du. How will you integrate 1 over u? Remember, we have treated this special type of integral that for us to integrate 1 over x is natural log of x or ln x. So we are going to apply the same principle here. To integrate 1 over u here, then it's going to be ln u, then which is equal to integral of f prime of x over f of x. What this one simply means is, if you have a fractional integral like this, if the numerator is the differentiation of the denominator, what you do is just take the natural log of the denominator. That will be the integration. Now let's take some work examples to illustrate this. Examples. Number 1, we have integral of 2x over x squared plus 1 dx. Now we say let f of x be the denominator, which is x squared plus 1. Then f prime of x, that is when we differentiate it, it will give us 2x. So you find out that when you differentiate the denominator, it will give you exactly numerator. Then we follow this format. Then we now say integral of 2x over x squared plus 1 is equal to integral of f prime of x over f of x dx. For that reason, we said that if the numerator is the differentiation of the denominator, what we'll do is just take the natural log of the denominator as your integration. This will be ln of x squared plus 1, then you add the constant of integration. Now let us look at number 2. if you are given the integral 2, if you are given the integral 3x squared plus 4x over x cubed plus 2x squared plus 7 the x, we are to integrate it. Now, as I've said, if you are given fractional integral, the first thing you do is just test if you differentiate the denominator, whether it will give you numerator. Then you now take the natural log of the denominator. Now, we say let f of x be equal to x cubed plus 2x squared plus 7. Then when we differentiate f prime of x, it will be, when we differentiate this one, this will be 3x squared plus 4x. When we differentiate a constant, it's 0. We find out that this, our differentiation, gives exactly what the numerator is. For that reason, we now say integral 3x squared plus 4x over x cubed plus 2x squared plus 7 is the same thing as integral of f prime of x over f of x dx, which will be equal to the natural log of x cubed plus 2x squared plus 7, then plus the constant of integration. Then let us take a look at another example. Number 3, we have to find the integral of tan x dx. Remember that tan x is equal to sine x over cos x, then dx. So you say let f of x be the denominator, which is cos x. Now let us differentiate cos x. When we differentiate cos x, it will give us minus sine x. So you find out that when you differentiate this denominator, it will give us the negative of the answer. The negative is not an issue, so we know how to deal with that. For that, we now say that the integral of tan x dx, which is equal to integral of sine x over cos x dx, is of this format, that is integral of f prime of x over f of x dx. Then you multiply it by the minus that it generates. At the end of the day, your answer is going to be minus natural log of the denominator, which is cos, to be ln of cos x, plus the constant of differentiation. Now let us look at another example here. Number 4 here, we are given the integral of cot x dx. And remember that cot x is cos x over sine x, then dx. We say let f of x be the denominator, which is sine x. Then when we differentiate it, that is f prime of x, when we differentiate sine x, it will give us cos x. You find out that when you differentiate this denominator, it will give us exactly numerator. That means the integral of cot x with respect to x, which is equal to integral of cos x over sine x dx, it is of the format of integral of f prime of x over f of x dx. For that reason, since it is of this format, you just take the natural log of the denominator, which is ln of sine of x plus the constant of integration. Thank you very much.